If you already program PLCs, you're most of the way to programming robots. People treat robot programming like a separate planet. It is not. The mental models map almost one-to-one. Scan-based logic, digital input and output, sensors, actuators, a cell full of equipment that has to coordinate. You already think this way. This video maps robot programming onto skills a ladderlogic engineer already has. What is the same? What is new? The two core moves and a full pick-and-play cycle. Let's cross you over. Start with what is the same, because it is most of it. In a PLC, every scan you read inputs and write outputs. On a robot, you do exactly the same thing. A digital input might be a part present sensor. A digital output fires a gripper or signals a conveyor. The input and output mindset transfers directly. There is no relearning there. Interlocks, the conditions that must be true before something is allowed to move, are the same concept. Handshakes between the PLC and the robot, where one waits for the other, are the same concept. Start and stop conditions the same. If you have wired a sequence of permissives and ladder, you already understand how a robot's cell coordinates. Now what is genuinely new? Motion. This is the one real gap, so let us name it clearly. A PLC rung energizes a coil. The output is on or off. A robot command moves an arm to a position in three-dimensional space. There is no on or off. There is a pose, a place to go, and a path to take to get there. That is the new vocabulary, and it is the bulk of what you're learning when you move from PLCs to robots. Everything else you mostly already have, so spend your energy here. Motion in space is the skill that is new. The two move commands every robot programmer learns are a joint move and a linear move. In UR script, they are movej and movel. A joint move sends the arm fast through joint space. Each joint rotates to its target angle. The tool gets there quickly, but it follows a curved path you would not want to predict. Use it for free air repositioning between stations. A linear move drives the tool in a straight Cartesian line at a controlled speed. Slower, but the path is exactly straight. Use it when the path matters. Approaching a part from above. Inserting. Pulling straight out. There is no ladder equivalent for these. Joint move to get there fast. Linear move when the tool path counts. Learn that one rule, and you have the core of robot motion. Next, frames. In a PLC, you have tags and registers. Name places where values live. On a robot, you have frames and poses. A frame is a coordinate system. There is a base frame, fixed at the robot's foot, and a tool frame that rides with the gripper. A pose is a position and orientation expressed in a frame. So instead of moving a value into a register, you move the tool to a pose. Once that idea clicks, robot programming feels like structured logic again. You're just operating on positions instead of numbers. The base frame is your absolute reference. The tool frame is where the work happens. Everything is a pose and a frame. Here is the part that will feel instantly familiar. A pick-and-play cycle is a state machine. The exact thing you would build in ladder as a sequence of steps. Step 1, approach. Move above the part. Step 2, grasp. Move down and close the gripper. Step 3, lift. Move straight up. Step 4, traverse. Move across to the drop location. Step 5, place. Move down. Step 6, release. Open the gripper and retract. 6 states, in order, each with an entry condition and an action. You have built this pattern 100 times in ladder for a conveyor or a stamping press. The robot version is the same sequence, just new instructions for the motion steps. This is why PLC and robot skills compound instead of competing. In the real factory, a cell is rarely all robot or all PLC. The PLC runs the line, handles the safety circuit, sequences the stations, and talks to the rest of the plant. The robot does the dexterous motion. They hand off to each other constantly. An engineer who can do both is far more valuable than one who can only do one. You already own the logic, the input and output, and the sequencing half. Adding motion, frames, and a few move commands makes you a cell programmer, not just a PLC programmer. That is a genuine career step, and the new part is smaller than you think. So if you program PLCs, robot programming is a short bridge, not a new planet. The fastest way across is to write the moves and run them. Start the robot programming course free at plcsimulationsoftware.com/robot-programming-course. It takes you from your first jog to a full pick-and-place, graded against a real goal. It is a real kinematics, real physics browser, sim running real vendor code, not a controller emulator, so the fundamentals transfer to a real robot. Free to start. Pro unlocks the full course and a certificate. The next video shows the same pick-and-place in 4 robot languages side by side. UR Script, Rapid, KRL, and Fanic TP. Subscribe. New video every Tuesday. See you in the next one.